I'm on page 16. Page 16. Sound like a plan? And I guess I should hook up to my things. 2, 6, 1, 7. Page 16. All right, ladies and gentlemen. So far, we have talked about the mean, which is the average. And what was a big important term I kept saying about what the mean was? What was it called? Expected value. So these all mean the same thing, and the mean is usually denoted by X with a bar on top of it. Good so far? We also talked about the median, which is the middle of the data. Okay? If you happen to have two values, because you have an even amount, you take the two middle numbers, add them together, and divide by 2. Or if you have an odd number, it's just the very middle number. Okay, so those are a few things. And then we kind of talked a little bit about the mode. And this is the most happening number or numbers. Numbers. We'll go with that. Okay, so if we had a number that happened 5 times, nothing else happened that many times, you have the mode. You could have, if you had two numbers that happened 5 times, that's the maximum amount of times that it happened. You would have multiple modes. So it's okay to have multiple modes. Okay, it's not like you broke something. Okay, so those are all ideas. Do we feel okay about that? Okay, these are all central pieces of data. The median does not get affected by large values to the right or to the left of what most of our data is doing. The mean does get pulled to the right or left drastically. Excuse me. If you have really big numbers. Okay, does that make sense? All right, so let's see what page 16 has to offer. The first thing we're going to talk about is something called the range. And all the range is the largest number, subtract the smallest number. Okay, so like if I had, let's say 100 was my biggest number and 30 was my smallest number, I would have a range of 70. Because 100 minus 30 is 70, right? Did I do that right? I hope. Okay, so that's relatively simple. And this just kind of tells us how far we're spanning. It's not really a major portion of data. It's another piece of it. Let's see, Alex. All right. So, minimum max, blah, blah, blah. So then we have, how do I do this? Okay. I have two things. So we're going to talk about the IQR. Okay, and this stands for interquartile range, which means this. Let's say I had a minimum value of 30. And let's say I had a median of 60. And let's say I had a maximum of 100. Okay, so notice we don't have the mean listed here. And we're going to have to talk about this interquartile range. So right now, what can you tell me about how much data is this way on it as a percent? What percent of my data would be to the left of the median? 50%. So 50% is this way. And that means if I went this way, I would have 50% of my data this way. So if you found the middle of the data, half the data is below it, half the data is above it. Agree? So now we have to kind of define something else. There's something here called Q1, and there's something here called Q3. Now, just as a disclaimer, the median could also be called Q2. It's not often referred to as Q2, but it could be. What this means is our data here, this would encompass 25% of my data, which means down here would encompass the other 25%. To give 25 and 25 gives me 50%. And then if I go this way, I would have 25% of my data in this region and then 25% in this region. So there's kind of a lot up here. It's not difficult, but when you look, if you just look up for the first time because you were reading a text that you couldn't go without, half the data is this way, half the data is this way. If I take the top part of the data, I have 25% of all the data that's within this certain region and 25% within this certain region. Or if I go to the left of the median, I have 25% of my data that would fall in some region and another 25. So the 25 plus 25 gives me 50, 25 plus 25 gives me 50, 50 plus 50 is 100%. Okay? So the interquartile range, the IQR, is the Q3. Oh, if I could make a Q, I'd be an incredible teacher. Q3 subtract Q1. Okay, so it's the middle 50% of the data. Okay, so I'm just trying to get some definitions, but I'll be able to show you a little bit more once this comes up. Okay. Another way to look at this is you would say, if you were to take your 25%, let me just highlight these. You have this 25, this 25, this 25, and this 25. So the IQR is also 75th percentile minus the 25th percentile. And I have percentage and percentile, so it's kind of a redundance. I could just say 75th percentile, but it's easy to, in my opinion, to say 75% of our data goes from the minimum all the way to Q3. 25% of my data goes from the minimum to Q1. 50% of my data goes from the minimum to the median, so on and so forth. There's all kinds of ways that we could mimic what this means. Okay. Let's see. I think you can find a and there's going to be one last thing we're going to talk about. Can I leave this screen, or is anyone still writing, jotting down? I didn't give you a lot of place for notes, but you can probably squeeze it. There's something called the standard deviation. Now, the standard deviation, usually we will use S. There's going to be another letter we'll use eventually, but we'll talk about that when we get there. And this is what the standard deviation equation looks like. Okay, this is the Greek letter sigma. Okay, and if you look at that, you're like, I don't think so. Lesson you. Well, my friends, we have our friend Desmos to help us on this, because that's, if you had like 20 pieces of data, in order to find the standard deviation, it's kind of a lot. So let's just label a few things of what this is part of. So the X bar is the mean. The N is the number of terms. Squared means squared. This x here is some observation of data. And then the Greek letter sigma means, basically in Stirrup's term, add up. Okay? So I want to do a small problem by hand, bless you, that there's no reason for you to write it down. Is that okay? Just kind of watch. Okay? So let's say I had a 5-point quiz I gave, and I found I had scores of this. Let's say those are my scores. Okay? It's only 6 people I tested. Okay? Well, let me ask you this, my friends. How would I find the average or the mean? What do you think? Any thoughts? Yeah. Number of terms. Okay, so I'm going to add them all up. So let's see. I got 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 3 is 13. Am I right still? 4, 7, 10. So it looks like if I add them all up, I would get to 15. And then I'm going to divide that by 6. Would somebody give me 15 divided by 6 to 1 decimal place? 2.5? Okay. So that's what our mean is. Okay. Relatively easy to figure out, yes? Is my math right? 1 plus 1, 4, 4, 7, 10, 15. Yep. Okay. So 2.5. So that kind of means if I were to say, hey, my mean and B, my numbers are in least to greatest number, my mean falls somewhere in here. This is where X bar falls as far as my data. And it's just looking at what the data is. Okay. I could find the median pretty easily. I could go 2 plus 3, which is 5. 5 divided by 2 is 2.5. So our median is the same thing. And that's just coincidental. It doesn't always have to be the same thing as the mean. All right. So if I went through our equation, this is what we would have to do for our equation. Because remember, our equation is this. So what I'm going to do here is I'm going to do this. I'm going to go 1 minus 2.5 squared plus 1 minus 2.5 squared plus 2 minus 2.5 squared plus 3 minus 2.5 squared plus 3 minus 2.5 squared plus 5 minus 2.5 squared, all divided by, and this is all under the radical, 6 minus 1. Now, I understand I only have 6 pieces of data, but does that seem like an awful lot of work for 6 pieces of data? Yeah. We all agree. The nice thing is, I'm not going to make you do that. Okay? There's all kinds of places that you can make errors. But I want to focus on one thing real quick before I show you how to go through. This, any of these, what can you guarantee the sign would be? Would it be positive or negative for all of those that I just highlighted? What do you think? And I know some of you are looking up there going, well, some of them might be a negative number. But before you say that, if I take a negative number in parentheses and square it, what will I always get? Positive. So all of those numbers come out to a positive number because you're squaring, whether it comes out to a positive component or a negative component. Okay? But my friends, that's an unbelievable amount of work. Okay? And again, I only have 6 pieces of data, that we're doing. Yeah, 20 pieces of data, we're going to run out of room. And we can make mistakes real easily. Agree? All right, so we have our friend Desmos that we're going to look at. And let's see. So the data I'm going to use is on the top of page 17. It looks like they have 1, 2, 4, 8, 10. Okay, so on the top of page 17. So let's go to our friend Desmos and see what Desmos has to say about this. All right, hey, we're at Desmos, yay. And I need to reduce that. Okay, so the first thing I'm going to do is, let me see where it's at. Is it here? Nope, that's not where I want to go. I go here. I'm going to go to the plus sign, and I'm going to go add a table. Okay, now this particular table has x1 and it has y1. We only have one variable we're going to use, so we're going to call our one variable x1. Is that okay? That's what it defaulted to. That's what we're going to stick with. Okay, now the nice thing about this table is if you were like in Algebra 1 and plotting data, you can put x1 and y1 in. You can put all your ordered pairs in, and all the dots are going to show up on the graph, which is kind of cool. But we're going to use a 1, the 2, the 4, the 8, and the 10. Okay, that's my data. So everyone agree? Everyone feel comfortable where I got that data? Again, it's at the top of page 17. It says we want to find the standard deviation. Okay, so then we come one below. We don't worry about y1 at all. All we worry about is just x1. Yes, I understand there's blanks there waiting for us to put y1 in. There's no reason to. We're just putting a string of that in. So you go, and we want to find the standard deviation. So we're going to go in here. We're going to go under functions, and we're going to go down to statistics. And you see that STDEV? I think it looks like DEV. So we're going to hit standard deviation. And this is where we might get hung up, but we're going to practice it enough. And if you get stuck on the test going, I can't get my standard deviation, and it's a goof up on Desmos because you can't figure it out, I will help you on Desmos. Don't panic. I want to find the standard deviation of x sub 1. Yes? So I'm going to go x. I'm going to go, let's see, it's shift underscore. Shift underscore is going to allow us to go lower, and then we can close the parentheses, but it gave us the answer regardless. So it looks like that data set of 1, 2, 4, 8, 10 has a standard deviation of 3.87 to 2 decimal places. Agree? Okay. Now, the standard deviation, because of when you looked at the original, it's never going to be a negative number. It's not going to be a negative number for a number of terms. I'm squaring quantities. If I square quantities, even if that quantity was negative, that will become positive. I'm adding up a bunch of positive numbers. I'm dividing by the number of terms, subtract 1, and then I'm going to take the square root. Well, we probably remember from Algebra 1 or Algebra 2, if you take the square root of a negative number, in Algebra 1, you said NRS for no real solution. And then for in Algebra 2, you might have started incorporating I for imaginary numbers. Okay? But we're not worried about that. It's just we know that standard deviation is always going to be positive. We have a standard deviation. Now, there's a couple of other things that I can do as well. Okay? Remember on the previous slide, I had a minimum, a maximum, I had a Q1, a median, and Q3. Remember that? So I'm going to go down one more box down here. I can go back into functions, and I'm going to go down, and I'm going to find statistics, stats. Let's see. And it looks like I have stats here. And if I do stats of x shift underscore 1, this is going to give us kind of a lot of information. It gives us our minimum. Our quartile 1 is 1.5, so that's the middle of the bottom part of the data. The median, which is the middle of all of our data. Q3, which is 9 in this case, which is the middle of our top 50% of our data, and then our max. So I bet you we could figure out the IQR just looking at this. IQR was Q3 minus Q1. Q3 is 9. Q1 is 1.5. 9 minus 1.5. 7.5? Is that right? Cool. All right, so I just covered a whole lot, and I didn't give a whole lot of definition of what things were. So let's think about this. So if we had, oops, I don't want the yellow. If I have some data, I can list it from least to greatest. I can find the median, which is the middle. Now, the nice thing is, if you have data and it's not in order, I imagine you could plug it in to Desmos, not in order, and I think Desmos might have an intelligence factor that's patient enough to do the order real quick. So Desmos really becomes our friend when we're dealing with this. It saves us a lot of time. Okay? We talked about just our data in general. If we had certain data that was listed, we had the median. Right now, the median cuts it into half above and half below as far as the data. And then we have, oops, let me change that to a blue. Then we have a Q3 and we have a Q1. And 25% of the data falls at each of these categories. And then the IQR, the interquartile range, is the middle 50%. And how I say the middle 50%, if I go from the median to Q1, I have 25%. If I go from the median to Q3, I have 25%. So it's the middle 50%. So it's Q3 minus Q1. Okay? Now, an important statement here is, it says, the standard deviation is the measure of spread. More specifically, it is the attempt to capture the average deviation from the mean. With data sets that are much more spread out, the standard deviation will be higher. The standard deviation is highly dependent. Highly dependent standard deviation is not resistant to measure. Extremely high and low values will have a significant and often unfair impact on the standard deviation of the spread. Okay, so this is not part of the lesson, but I just want to talk about if I have a normal curve that looks like this with my data, or if I have a normal curve that looks like this, does everyone feel the bottom one is fatter? Okay, so this is what we're looking at. This is where our mean would fall on each of these. And there's a certain region to the right and to the left that is our standard deviation. And right now we are one standard deviation from the mean. Okay, standard deviations usually go up to 3, but they could go much higher. You could go 4, 5, 6, or whatever. So that's a little bit more than we were necessarily willing to cover. But what I want us to do is I want us to be able to play with Desmos. And then make sure for standard deviation, I think you can type this in. You don't have to necessarily find it. And then you're going to do X1. So in order to get X1 on Desmos, you type in X, and then you go Shift underscore and then 1. And that'll allow you to do a subset or a lower value. Okay? This was 1-7, so let's see what we have to play with tonight. All right. So let's have you try page 115 and 116. I'd like you to work for a few minutes, see if you could just start playing around with Desmos on it. But I bet you you can get most of this. You might not be able to answer every question, but we'll definitely go over the questions tomorrow in class. Sound like a deal? I'm really happy to see you all back today. Happy day.